page 40 on your notes. So, what we're looking at is regions, okay? So, you'll be given the equation of 1, 2, maybe 3 curves, okay? And you need to graph all those curves onto the same number plane, and you're going to shade the region that's bounded by the curves with the conditions that we're about to look at on your notes, okay? So, inequalities can be represented on the number plane. A point is tested to see whether that point is included in the region, okay? Now, I'll touch up more of these notes as we go through the question. So, all the information is there, and I'll go through that as we answer the question. Okay, so example A. Indicate clearly on separate diagrams the region determined by the following inequalities. The first one, y is less than or equal to 2x plus 1. Right? So if you treat the inequality as an equal sign, what sort of graph do I have? Straight line. Okay, so we need to graph that straight line, and then we're going to have to shade a region that is defined by that straight line. Okay, so I'm going to use GeoGebra today, a couple of things, because one, it'll give us a nice accurate diagram, and two, to show you how to use it, okay, to this topic. So, can everyone please draw up a number plane, ready to graph? I'm going to be using technology, I'm not going to use the graphing, I've been graphing everything else. And let's sketch that function represented by that, treat it as an equation. Okay, so y equals 2x plus 1. Let's graph that using your intercept skills. And then we'll have a look at the regions component. Right, so GeoGebra, this app's called, okay, it is a Apple app. I'm pretty sure it's also an Android app if you've got a tablet. Otherwise, the website will give you the software that you can download for free. Okay, it's a very handy tool, particularly for this topic, to have a look at some certain things. Alright, so down the bottom is the input bar, okay, and that's where you input all your information. Right, so I'm just going to put the equals component, so y equals 2x plus 1, okay, and that will give you your line, okay, in there. And don't forget, when we graph these lines, we need to show arrows through the line, okay, because you are representing a function that is continuous. You also need to show your intercepts by writing down the value, what they're equal to, okay, and we've gone through that in the previous lesson. And when you are labelling your axes, y, x, however far out you go, and you've got arrowhead on all 4 ends of your axes. Okay. Now this one up here, y, or it is f of x. Okay, doesn't really matter. Up there, I'm not concerned at all with what's labelled up there, but you of course need to know what f of x means. Right, so that's the equation of the straight line. Okay, with all that information in there. So, we are now looking for the region, okay? So we need to either shade the section below the line, like this, that's defined by the inequality, or we're going to shade the region above on the more left side of the line. That will define that inequality, okay? So, the way we do that is we test a point, okay? So we pick a point on the number plane that is not on the line. You substitute the x and y value of that coordinate into the inequality and see what answer you get back for your inequality. So, what would be the most sensible point to test? 0, 0, the origin. Okay? So, we're going to test that section. So, test 0 and 0. So, you need to pick a point that is not on your line or curve. Then you substitute your x and y value into the original inequality. So y is 0 is less than or equal to 2 lots of 0 plus 1. Then you tidy it up. 0 is less than or equal to 1. Is that a true inequality? Yes. Okay? So, if it's a true inequality, then what you need to do now is shade the region that includes that testing point. Okay? So, you are shading this region here. Okay, I didn't do it in shade there. Yep, something along the lines of what's Robin done here. Yep. Okay, the line obviously goes a lot further out from there. Okay, the second thing I need to point out, I'm going to pick a point on the other side of that line. Okay, so let's pick this point here. Just a point in general on the other side. So test that coordinate, which is -1, 0. So substitute your x and y value of that coordinate into the original inequality. Is 0 less than or equal to -1? No, okay? So it doesn't matter which side of your graph you pick, it will work either way. So if it's not satisfied, the inequality, okay, so it's not equal, not less than or equal to, and the region you shade is in the opposite side of that graph or line, okay? So if that's not defined, it's not true, the point's on this side of the line. That means when you shade the region, you're going to shade the opposite side, the other side of that region. Okay? So if the point satisfies the inequality, you shade the area where the point is on the side of the curve or line. If it does not satisfy, you shade the other end. Now, the useful thing with GeoGebra as well is you can put inequalities in there as well. So y is less than or equal to 2x plus 1. Right, and it will show that region there.
How do you show, is it a dotted line if it's not equal to?
Yeah, we're about to get there. Yep. Okay. So, Robin's jumped the gun on what I wanted to say next. Anyway, we'll go through it and we'll pick it up from there. Right. Does everyone understand the principle of what we're doing? Yep. Right, let's try the second one. Y is greater, y is greater than x squared plus 1. Alright, so you treat it as an equals, you work out what your graph is, And before you sketch it, there's one other thing that Robin just brought up that I was about to say. Right, so when we're doing, so you can set up your number plane and listening while you do that. When we represent these on a number line, if we have a greater than or equal to component or less than and equal to component of the inequality, we have a filled-in circle at that value. If there was just a strictly greater than or strictly less than, we represent that on the number line with an open circle. Okay, so for example, x is greater than 3. So at 3, there'd be an open circle. Alright, if x is less than or equal, x greater than 3, and the line goes to the right. There. X is less than -2, so at -2, because there's also an equal component there, we will have a closed circle at that point and draw your inequality. And that's what we did way back in chapter 2 or 3. So, the first question was y is less than or equal to 2x plus 1. So when you have the equal component, you are drawing an unbroken line. When you have a component that's just greater than or just less than, you need to do a dotted line, or, in other words, a broken line. So, what type of graph do I have for x squared plus 1? Parabola. What can you tell me about the location of the parabola? Go on. Yep. Okay, you go across if it was x plus 1 or squared. Okay, that's when you'll go across. When you're adding constant, you go up again. Alright, so remember your x and y intercept skills? Right, if you don't know exactly where that lies, okay, but using some understanding, you should be able to tell me there's a parabola with the vertex at y equals 1, and there are no x-intercept because we have a concave up parabola. So, in the input bar, so we've got y equals x, up arrow, squared, plus 1, and there's our parabola. Okay? Right, so you need to draw your parabola with your arrows. You need to label your x, y axes with arrows and any x and y intercepts. Okay, so there's no x-intercept, there is a y-intercept, you need to label that. Right, so you don't need to write 1, 2, 3, 4, 5, you don't need to do any of that. You just need to label where intercept points are occurring. Alright, so from that you pick a point. Alright, somewhere on the number plane that is not on the line of your, in this case, function. Okay, so the typical one you do is the origin, if you can do it, because that's a nice, easy, simple, quick calculating number to work on. But it won't always be the case. Sometimes you'll have intercepts at the origin and you'll need to pick another point. So, after you've drawn your graph, I forgot to say, y is greater than x squared plus 1. Okay, so may not be able to see very well, but it's a dotted line. Alright, because you just got the greater than or equal, you just got the greater than in this case, so you need to draw a broken curve. Okay.
Well, then you fail, just write it again.
Okay, so while we're learning it, it's okay, but obviously we're answering questions. We need to make sure we do it right, and that was partly my fault because I didn't say anything on it. Right, so we can see the region's been defined as inside the parabola. Alright, so let's test a point. The test doesn't have to be the origin, okay? However, like I said, it's a nice, quick, simple, and easy calculation to do. The test at 0, 0. Alright, so that's the point that is not on the line, on the curve, sorry. and then substitute that into your original quality. So 0 is greater than 0 squared plus 1. So is 0 greater than 1. Alright. 0 is not greater than 1. So the region you shade is going to be on the opposite side of the curve or the straight line from that. So the point we tested with the origin, which was outside the curve, right, it did not satisfy the inequality, so we shade the opposite section, so it will be inside the parabola. Now when you shade it, okay, so ignoring that's not tidy, when you shade it, all you really need to do is just some lines like that. Okay, and of course we've got these broken lines here. Okay, that's all you need to do. Okay, you're not literally colouring it in, okay, because that will take up time. Right, so just some diagonal dash, strokes, dashes, whatever you want to call them, will be adequate enough for what we're doing. Right, any question? Right, so now we've looked at a case where we've got an equal component, and we've just covered a case where we haven't got the equal component. Alright, so now we've got that skill, let's step it up. So, x take away 2, all squared, plus y take away 1, all squared, is less than 9, and y is greater than or equal to the absolute value of x. So, to answer these questions, we will do each of those two graphs separately on the same number plane. You'll do the region for both of those, and then you'll need to shade in a different way the common union of your region. Okay? So, good. So you need to identify what type of graph you have from what we've already covered this topic. Using those skills, having a sensible layout of your graphs, need to be reasonably accurate, thinking about intersection points, etc. And then provide a sketch. So, you should know this is a circle, okay? You should then be able to tell me what the centre and the radius for the circle looking at this. Okay? Circle, centre at 2, 1, and the radius equals what? Square root of the whole number of n. Okay? Radius is 3. So thinking about things like circles and the region, so less than, some things will become very apparent quickly in terms of where the centres are. That looks more like an oval, doesn't it?
Why is that more?
Hey?
Why is that an oval?
Because of the calibration.
So it's just
Calibration, yeah. Okay. Now, for the circle, right, where the intercepts are not so obvious, okay, I'm not requiring you to go ahead with the intersection of those points. However, when you're told that the radius is 3 and the centre at 2, 1, that information should tell you that the circle will intercept all both axes, okay? I would suggest you would write the highest and lowest points on your axes for that circle. Okay, so the radius is 3, so we go 3 on either side of 2, and we mark that on the axis at the end of the circle. Because finding the intercepts will just take up a bit of time. When we're not interested in that, we're just interested in the region in this case. Alright, and then the radius is 3, so we need to go up and down 3 from the y value is 1. Alright, so if we intercepts are not so obvious, I would suggest you do that sort of approach on your sketches. Alright, so you have a less than 9, so the circle should be a dotted line around. Alright, so graphing in pencil first, a light circle done, and then you can go around in your pen and do your dashes. Okay, so if you do a unbroken curve, alright, you will start losing marks. And then you need to check the point. Okay, so you need to pick a point somewhere on the number plane that is not on the curve and substitute that point into your inequality. Has everyone got their circles drawn? Yep. Right, so because I know it intercepts the x and y axes twice, right, so I know the origin is going to be included in that circle. So I'm going to substitute, that's going to be my test point. The test, 0, 0, so -2 all squared plus -1 all squared is less than 9. So 4 plus 1 is less than 9, is 5 less than 9. Okay, so yes. So we will shade the region inside that circle. Okay, and when I say shade, I mean doing something like this. And I'll probably put the intercepts of the centre of the circle as well. So? Yeah, so now you're going to have, instead of one graph, you're going to have 2 on the same number plane. You're going to find the region defined by the second graph, and then where they overlap each other, that'll be your union region. Okay? So, y is greater than or equal to the absolute value of x. So who remembers what that graph looks like?
B.
Absolute values are V-shaped graphs. Y is greater than or equal to ABS, absolute x. Okay, so when you put absolute value functions into the input bar, ABS, then brackets, x, and there's that graph there. Okay? So, we first need to shade the region defined by the absolute value graph, and then from that we will shade in a different setting altogether the common union between them. Okay? So, it is greater than or equal to, so this one is an unbroken line. Right, so from that you need to pick a point. This time you cannot pick the origin because the origin is part of your function there. So you actually need to go and pick another one. Okay, doesn't matter where, it'll work for all instances. Alright, so I'm going to do, can't pick 1, 1, so I'm going to do 0, 1. At some point where it's inside or outside your function or your graph, if you don't have a function. Right, so is 1 greater than or equal to the absolute value of 0? So is 1 greater than or equal to 0? Okay, so yes, that's satisfied. Okay, so we shade the region. When you do the shade, you'll do a different slope. Okay, so I'm going to do some of this. Perhaps a different slope. And then where those two regions overlap, you then need to shade in a different slope. Okay, so I might do horizontals. Do something more like this now.
Doesn't look very good, does it?
Yeah, okay. So the final thing you need to do is, with an arrow pointing like that into the correct region, into the final answer, and then capital R for region. Okay, so just make sure that you are telling whoever's marking your exam that you know what you're doing. Okay, you understood. Okay, so you need to shade the region for both sides, both functions, or sometimes you can have 3 examples, and that might be one of the questions towards the end of the exercise. Alright, so you need to do the region defined by each of those functions or graph, and then the common union where they all overlap, that's where you shade it all in at the end. Okay? Question? We're good? We're good? Right, so GeoGebra is useful, helps you to check your answers. Also helps you to look at some graphs, look at some features, etc., etc. One more. So, y is greater than 4 on x, and y is less than or equal to 2x. So, less than or equal to x plus 1. Okay. Have a go. I'll put the answer up at the end. So you need to sketch the region by the first one, y is greater than 4 on x. Sketch the region for y is less than or equal to x plus 1. Just while you're on that, on the left side, they're all got circles. If you click on the circles, okay, it'll appear and disappear on your graph, okay? So if you want to look at something specifically, you can unselect those circles for the function and then incorporate that into your answers as you're going along. So y is greater than 4 on x. What type of graph do I have there? Hyperbola. Okay. Thinking about where it lays onto your number plane. Also thinking about it is just greater than, so what we need to do for that.
You failed.
Okay, and that's one other benefit of using pencil first. You can go over it properly in pen once you're happy. And don't forget as well, a rough sketch is always beneficial because you can do a rough sketch very quickly compared to an accurate sketch.
Oh wait, are they on the same graph?
They will be on the same graph, yeah. Because the question will say y is greater than 4 on x and y is less than or equal to x plus 1.
Just a line of 1.
So,
No, just a line of 1. That is
with what slope? With what slope? Well, when you say a line at 1, where does the line go after 1? What, horizontally, is that what you're saying?
Just a line.
What's the gradient?
Hey.
Okay, so after you've drawn the hyperbola, dotted hyperbola, because you just got the greater than, thinking about your asymptotes as well, y is greater than 4 over x. Y is greater than 4 on x, and there's the region. Okay, you need to remember your asymptotes.
I feel as if I definitely. Oh no, my graph is right. I just didn't shade it in. I was like, cool, I got that wrong. Nope, just didn't shade it.
Okay, there's your hyperbola.
So the number on top just makes it steeper.
Yeah, because you're multiplying 1 on x by a constant of 4.
So it makes it less steep.
Yeah, because of the reciprocal, yeah.
Less steep.
Okay, so this one here, that's your 1 on x. Okay, and this is your 4 on x. Okay, because it's a reciprocal value. Okay, but in general, if you do the basic graph of y equal 1 on x, you will get away with it. Okay, for this style question, because you asked for the region. There. Okay, so remembering there is an asymptote of the y-axis and the x-axis. Okay, so considering that when you do your sketch. And because you've got an unbroken part of your curve, you'll need to test in more than one spot. Okay, because of the asymptote in the y-axis, when x equals 0, alright, I would pick the point on either side of the origin. Okay, and then go from there. You also need to be careful that when you pick your point, it is not part of the function itself. Okay, so test. I'm going to go -1, 0. Because of the asymptote, I'm not going to test any x value equals 0. Alright, so I'm doing a quick check. -1, 0 is not part of your original function. Okay, don't put a point in there that is on the line of the function. So, is 0 greater than 4 over -1? And of course, that's why we can't put x equals 0, because we're dividing by 0, if that's the case. So, is 0 larger than -4?
I think so.
Okay, so 0 is a number that's greater than -4. Okay, so on the right side of the left side, so the origin, and between the asymptote, you are going to shade the region above that curve on the uppermost part of the curve, and don't forget you go right down in the third quadrant closer and closer to the axis as you've got drawn in your notes. And, of course, in the third quadrant, closer and closer to the horizontal. Okay, so this will probably be a more extension style question in terms of furthering your thinking and understanding. Made sure I've got all bases covered so there are not too many surprises when you do your HC exam. Alright, y is less than or, sorry, we've got to test the other point because of the asymptote. So I'm going to go 1, 0.
You have to test the points inside the curve as well.
well, if I test it on this side, I can see that it's not going to satisfy. And if I test point inside, it is going to satisfy. Right? So you've got to treat that vertical asymptote as the break on either side. So you test on either side of that. Right, so test at 1, 0. So is 0 greater than 4 on 1? Is 0 greater than 4? Okay, so 0 is not greater than 4. So the point is on the left side of the curve in the positive x direction. Alright, so it doesn't satisfy that point, so we need to shade the opposite section. Okay, so I only need to test one point if there were no asymptotes there, but because of that vertical asymptote, I need to test on either side. Alright, y is less than or equal to x plus 1. Okay, so less than or equal to means you're going to have an unbroken line. Right, so I know the y-intercept is 1 and the gradient is also 1.
That's what I have.
Alright, so you're going to label your intercepts 1 and minus 1. Okay, you can also find the x and y intercepts, and that will give you enough information for the line. Alright, and I know that the curve does not go through the origin. Okay, the curve being a straight line in this example. So I'm going to test the origin now. Okay, you can pick whatever point you want as long as it's not on the line or curve. Alright, and then use your understanding of whether it satisfies or does not satisfy that inequality to shade the correct region. So is 0 less than or equal to 0 plus 1? Is 0 less than or equal to 1? Okay. So 0 is less than 1, yes. Alright, so I will do a different gradient sketch, whatever you want to call it. Okay, something like that. Okay, so assuming I've already done that section there, done in that pattern. Okay, so that's all you need to do. You don't need to colour it in. Okay.
Mine looks great.
And where those two regions are common, I'll probably do something more like this. Something like that, right? And then, just to make sure that it's not overly confusing, put an arrow in that region where you have your answer, okay?
Is that it?
That's it.
We're done.
We are done.
Prelim course done.
Woo!
Okay, so that's now all of chapter 5 can be done. Except for the extension stuff, we'll finish that on Friday, tomorrow.